Section 10.5 is hydrates. This is your last section for chapter 10. What we're going to do with hydrates is that we're going to take something that's ionically bonded, and within that structure we are going to have some water involved. So these are compounds that incorporate water within their structure. The example here is copper sulfate. Dot. Now the dot is not a multiplier. I basically call it a separator, just to separate out how you've got your cupric or whatever, your copper sulfate, and then how many waters are inside that molecule. You have used this 3 or 4 times already in class. It was the blue stuff. We heated it. It turned white. You've taken the water out when it turned white. So what we do is we notice what the ionic compound is in the beginning, the cupric sulfate or copper sulfate, and then we have to identify how many waters are within that structure. So it's pentahydrate. So if you've got the water, you use a prefix in front to say how many. So the other one we've used quite often is magnesium sulfate heptahydrate. So we have 7 waters. So this is how we would name them and how we would identify them. How we're going to solve for mathematically is next. So what we've got, we have a hydrate of aluminum bromide is composed of 71.16% of AlBr3 and 28.84% water. What's the formula for the hydrate? So you have to figure out how many waters are there. What would be the number that would go in front of the water? First thing we have to do is, again, we're going to get rid of the percent and make it into gram, because we know that if we've got these percentages, they add up to 100. We can drop the percent and put it into a gram. So we are going to change both of these into moles, just like we did for empirical and molecular. There you go. So we're going to take the whole compound's molar mass. So the Al and the Br3 all together. It doesn't want to work today either. All right, so 71.16 grams of AlBr3. We're going to divide that by the molar mass, and that's 267. I added up 1 aluminum and 3 bromine for 267. Once we divide that out, we're going to get 0.267. 0.267 moles of AlBr3. The next thing we're going to do is take the percent of water, change that into grams, and divide by water's molar mass. So 28.84 divided by 18. And we're going to get 1.60
moles of water.
Now once we have them into moles, what we're going to do is we're going to take water divided by other every time. Water should always be the bigger number, so you should always take the water divided by the 0.267 in this case.
Do we need to do this divided by 2 or 0.267?
Well, it will always end up being a 1.
That's true.
So your coefficient in front of the ionic compound is always going to be a 1.
So
really we just want to find out the water part, so we don't have to mathematically do it.
So
once we divide that, we end up getting 6.
That's easy.
That tells you that there are 6 waters.
That's a whole number. You don't need to do much.
So now what we have to do is we've got to write it out. 71.16. No, I'm done with that part. How about AlBr3
dot,
not a multiplier, just a separator, 6H2O.
Although you will see it sometimes as an X, not a dot.
I've
seen it in college as an X.
Nice.
But most of the time it's going to be a dot.
All right.
So there is your formula for your hydrates. So you can figure out percent composition, you can figure out empirical formulas, molecular formulas, and hydrate formulas.
Fabulous. Chapter 10, done.
Yay.